All right, we have a system of equations here. We are going to solve this system of equations using the substitution method. So you have probably learned the graphing method by this point. You've learned the elimination method. We're going to look at the substitution method. Sometimes the quickest and easiest, sometimes not at all quick or easy. But in this case, it's pretty good. These are both set up in y equals mx plus b form, which means they are easily graphable. I could go graph these, find out where they intersect, but you'll notice some of these numbers are kind of big. If we're graphing it on paper, we might not be able to fit these numbers on our graph. We could always use a graphing calculator or Desmos, but it's quick and easy just to use the substitution method. So what the substitution method is all about is recognizing that this right here is equal to y. 6x plus 14 is equal to y. It's the exact same thing as y. If it's the same thing as y, then it can replace y anywhere else where I see y. Here, I see y. So I'm going to rewrite this whole equation down here, but I'm going to make a substitution. I'm not going to use y here on the left side of the equal sign. I'm going to keep the right side, negative 4x x minus 16. But instead of putting y here in blue, I want to make a substitution. What is equal to y? Well, 6x plus 14 is equal to y. So that's still y equals negative 4x minus 16. I just made a substitution here. Instead of showing y, it's something that is equivalent to y in its place. Let me get rid of the blue because that's just in the way. So this is now an equation that we created. We kind of combined both of these equations into one new equation that has only one variable, and that is solvable. I can solve this equation using opposite operations. I see a negative 4x. I can add 4x to both sides. That gives me 10x. I need space. 10x plus 14 equals negative 16. I can also get rid of the plus 14 by doing minus 14 to both sides. 10x equals negative 30. And from there, I can tell that x equals negative 3. Can't tell? We divided everything by 10. X equals negative 30 divided by negative 10. X equals negative 3. This is half of our answer, not our full answer. Because remember, our full answer needs to be the x and y that make both equations true. So if I know x equals negative 3, I know this is going to be my solution once I find the y. So we're going to come back up to either one of these equations. It doesn't matter which one. I like the top one. It's positive, nicer to work with. I'm going to bring it down here. Y equals 6x plus 14. But we know what x is equal to. X is negative 3. So this can be 6 times negative 3 plus 14. Well, that is negative 9 plus 14. And negative 9 plus 14 is positive 5. So y equals positive 5. If I were to graph these two equations, they would intersect at the coordinate negative 3, positive 5. If I needed to plug in an x and y value, this has an infinite amount of solutions. This equation has an infinite amount of solutions, but there's only one equation that they both have at the same time, and that is negative 3, positive 5. So I can put that in for x and for y, both. It is the only coordinate that works in both equations. That's the substitution method. Let's look at one more example of the substitution method. Standard form equation mixed with a slope-intercept form equation, but same concept. They tell me, the problem tells me what y is equal to. Y is equal to negative 2x plus 1. That means anywhere else where I see a y, like right here, I can replace that y with negative 2x plus 1. So I'm going to rewrite this equation. It's going to be 3x plus 5y. I'm not going to put the y there, though. I'm going to make a substitution. Actually, I'm going to leave big empty parentheses. Equals negative 30. Instead of saying 5y, I'm going to say 5 times this guy, right? This right here, negative 2x plus 1. Y is equivalent. So this is still the same equation. It's still 3x plus 5y equals negative 30. There was just a substitution made. Instead of saying y, we said something equivalent to y. It's like instead of giving you $1, I could give you 4 quarters. It's the same thing, but just different. This is y, but different. What's good about this new equation is that it only has one variable. If there's only x in it, we can solve it. So that's what we're going to do. I'm going to distribute. That is negative 10x plus 5 equals negative 30. Bring down this 3x. I can combine like terms. This 3x minus 10x is negative 7x. I know I need to get rid of plus 5, so I'm going to go ahead and minus 5. Kind of take 2 steps out of the way with one. Do 2 steps in one. Plus 5 minus 5 cancels out. I have negative 7x equals negative 35. Divide by negative 7, and we get x equals positive 5. This is half of our answer. Don't quit yet. We're not done. X equals positive 5. That means my answer is going to look like this. Come back to our equations given to us. This bottom one looks easier to work with. I'm trying to find what y is, and that tells me what y is. Y equals negative 2 times x plus 1. But what's x? Well, x is 5. So negative 2 times 5 plus 1. That is negative 10 plus 1. So y would equal negative 9. That is my solution. And again, that is the coordinate where these 2 lines would intersect. That is the coordinate where I could plug in 5 for x and negative 9 for y. It's the only number that would make both of these equations true at the same time. So that is the substitution method. Good luck.